All right, let's dive right in. Today, we are going to decode a technology that honestly sounds like it's straight out of science fiction, but it's on the verge of changing pretty much everything. And believe me, it's happening a lot faster than you might think.
So just start with this question. What if we could take on humanity's absolute biggest challenges? We're talking about curing diseases, reversing climate change, and solve them not over lifetimes, but in a matter of seconds. It sounds impossible, right? Well, that is the incredible promise of the quantum revolution.
To even begin to understand that future, we first need to get our heads around the fundamental shift that's happening right now. We're about to leap from a world built on simple, everyday switches to something a lot stranger and unbelievably more powerful.
Okay, so the heart of this whole revolution comes down to one core difference. Everything you use today, your phone, your computer, it all runs on what we call classical bits. Think of them as light switches. They can be on or they can be off, a 1 or a 0. Simple. But a quantum bit or a qubit, that's a whole different ballgame. The best way to think about it is like a spinning coin. While it's spinning in the air, is it heads or tails? Well, it's kind of both, right? A qubit can be a 1, a 0, or both at the exact same time. And that one little difference, that's where all the magic starts.
Now, that mind-bending spinning coin state actually has a name. It's called superposition. It's this bit of quantum weirdness that allows a single qubit to hold and process an enormous amount of information all at once. But here's where it gets really wild. When you link qubits together, their power doesn't just add up, it grows exponentially. We're talking with just a few hundred stable qubits, you could process more possibilities than there are atoms in the entire known universe. Just let that sink in for a second.
And look, this is not just some theory on a whiteboard anymore. The race is on. We've already hit a milestone called quantum supremacy. That's the moment a quantum computer does something that no classical computer on Earth could practically solve. Giants like Google and IBM have already built processors that have done calculations in minutes that would take our world's best supercomputers thousands of years. The proof is here. This is real. Okay, so these machines can do a ton of math really fast. But what does that actually mean for us in our daily lives? This isn't just a science experiment anymore. This technology is getting ready to rewrite our world in some very, very real ways.
Let's start with something that affects every single one of us: healthcare. You see, molecules are basically tiny quantum systems, and our current computers are, well, they're terrible at simulating them. But quantum computers? They speak the same language. This means we could design revolutionary drugs from the ground up, molecule by molecule. We could finally enter an era of truly personalized medicine, with treatments designed specifically for your body, for your DNA.
But with all this incredible power comes a pretty serious dark side. All the encryption that protects our bank accounts, our emails, our entire digital lives, it's based on math problems that are just too hard for normal computers to solve. But for a powerful quantum computer, those problems could be like simple addition. This is a massive threat, no doubt about it. But it's also kicking off a huge race to invent what's called post-quantum cryptography, brand new ways to keep all of our data safe in this new era.
So, what happens when you take one world-changing technology, like AI, and combine it with another, like quantum computing? You get a future that is completely supercharged. Quantum computers could help us create AI that's far more powerful than anything we can imagine today. It could solve insanely complex optimization problems in an instant. Think completely untangling global supply chains or designing perfectly efficient energy grids. It's a total game changer.
Now, it is very easy to get swept up in all the hype. And believe me, the potential is incredible. But we need to take a breath and ground ourselves in reality for a minute. There are some really significant hurdles we have to clear before any of this becomes widespread. You know that quantum weirdness we talked about? Well, it turns out it's incredibly fragile. I mean, the slightest little disturbance, a tiny change in temperature, a small vibration, can make a qubit crash out of its quantum state. That's a process called decoherence. So right now, the biggest challenge for scientists is just figuring out how to build and scale these computers in a way that's stable and can correct its own errors without destroying the whole computation. It's a massive engineering problem.
So let's talk about the actual roadmap. Where are we today? Well, right now, we're in the early breakthrough era. We're proving it can be done. As we look ahead to 2030 or so, we expect to see the first real-world uses in very specific, high-value areas. Things like drug discovery or complex financial modeling. But the huge, society-changing impact that everyone talks about, that's probably further down the road, likely in the 2040s and beyond.
And if you ever wonder how seriously the world is taking this, all you have to do is follow the money. We are talking about billions, with a B, being poured into R&D by both governments and massive corporations. This has gone way beyond a simple scientific project. It is now a full-blown global race for economic and, frankly, geopolitical dominance.
But a revolution this big isn't just about the technology or the money, it's about people. It's about us. So what does all of this actually mean for our jobs, for our security, for our society as a whole? We are absolutely looking at a major shift in the workforce. On one hand, you're going to see these incredible new jobs pop up, roles like quantum machine learning analyst or quantum algorithm designer. But on the other hand, entire industries that are built on the limits of today's computers, think about traditional cryptography. They're going to face some serious fundamental disruption.
And whenever you're talking about this level of power, you have to start asking some really big, really tough questions. Who controls this technology? How do we even begin to prevent its misuse? What does privacy even look like in a world where today's encryption is useless? And what about bias in algorithms, but now on a quantum scale? These are not theoretical questions for the future. They are debates happening right now.
So, when you're faced with a change this massive, it's totally normal to ask yourself, okay, so where do I fit into all this? How can I possibly prepare for a future that's literally being invented as we speak? Honestly, the most important thing you can do right now is just stay curious. You don't need to quit your job and get a PhD in physics. Just follow some reliable tech sources, maybe watch a few introductory videos online to get the basic ideas down. The first step to being prepared for the future is simply understanding it.
And this is a really important point. You do not have to be a physicist to be part of the quantum revolution, not at all. This new industry is going to desperately need people who can explain these ideas. It's going to need ethicists, designers, project managers, and strategists. There is absolutely a place for everyone in this new future.
So here's the bottom line. The quantum era isn't some distant what-if anymore. It's arriving. It's happening. The real question is no longer if it will get here, but when. And when it does, are we going to be ready for what comes next?